Now, let us try to establish the relation between Celsius scale and Fahrenheit scale, which means that how to convert Celsius into Fahrenheit and Fahrenheit into Celsius. That is what we are going to prove, or we are going to derive an equation which converts Celsius to Fahrenheit and Fahrenheit to Celsius. Let us start. The relation between the two above scales can be found as, we use this basic formula, which is T minus LFP divided by UFP minus LFP. What is this LFP and UFP? LFP is nothing but lower fixed point and UFP is upper fixed point. Okay. Now we use this basic formula. T is any arbitrary temperature on a given scale. T minus LFP divided by UFP minus LFP in Celsius scale, which is equal to T minus LFP divided by UFP minus LFP in Fahrenheit scale. This is the fundamental equation to establish relation between Celsius and Fahrenheit. Okay. If you equate this equation with this equation is in Celsius scale and this equation is in Fahrenheit scale. Let us equate these two equations. Okay. So T is any arbitrary temperature on a given scale. This is the Celsius scale and this is the Fahrenheit scale. LFP lower fixed point and UFP upper fixed point. Now when you substitute the values of lower fixed point and upper fixed point, now we have lower fixed point in Celsius scale. In the earlier diagram, or the diagram which is there in earlier slide, I told that lower fixed point is 0 degree Celsius. Okay, in Celsius scale. Upper fixed point is boiling point of water in Celsius scale is 100 degrees Celsius minus lower fixed point is 0 degree, which is freezing point. One thing you have to observe here, lower fixed point is freezing point, upper fixed point is boiling point of water. Okay, so in Celsius scale, lower fixed point is 0 degree Celsius, freezing point of water. Upper fixed point is 100 degree Celsius, boiling point of water, which is equal to T, which is in Fahrenheit, put it as degree Fahrenheit, minus lower fixed point, which means that freezing point of water in Fahrenheit scale is 32 Fahrenheit. Upper fixed point, I mean boiling point of water in Fahrenheit scale is 212 Fahrenheit minus again lower fixed point 32. When you equate these two equations, only unknown things are degree Celsius and degree Fahrenheit. When you equate these two equations, you will get degree Celsius is equal to 5 by 9 into Fahrenheit minus 32. This relation will help us to convert degree Celsius into Fahrenheit and Fahrenheit into degree Celsius. Okay. Now let us solve an interesting and important problem related to temperature scales. This problem is widely asked problem in your university exam as well as many competitive exams. The problem is, what is the temperature whose value will remain same in both the Celsius and Fahrenheit scale? I repeat the question, what is the temperature whose value will remain same in both Celsius and Fahrenheit? The question is, there is a temperature value and whose value is same in both Celsius and Fahrenheit scale, which means that there is a particular value of temperature, and if you convert that value of temperature into Fahrenheit scale, you will get the same value. I mean, no need to convert that Celsius into Fahrenheit because both the reading will be same. What is that temperature? To solve the temperature, let X be the same temperature in both scales. That is what we need to measure. Let X be the same temperature in both the scales. Okay. This is the fundamental formula we have derived in earlier slide to establish relation between Celsius and Fahrenheit. We know that there is a particular temperature which we need to find out. The temperature is same in both Celsius and Fahrenheit scale. Let that temperature be X. So in degree Celsius is also X and Fahrenheit also X. So if you equate or if you solve this equation, the x value will be minus 40 degrees Celsius. Okay. So this is the minus 40 degrees Celsius temperature, which will be same in both Celsius and Fahrenheit scale, which means that if you convert minus 40 degrees Celsius, you will get minus 40 Fahrenheit. So that is what the meaning of question is. Minus 40 degrees Celsius is the temperature which will give you a same value both in Celsius and Fahrenheit scale. Now let us discuss another important concept related to temperature. Okay, that is thermometric property. Thermometer based upon the principle that if the temperature of a system changes, then some of the other properties of a system also change. Such properties are called as thermometric property. I try to explain this. We know that when you supply some amount of heat to any body, then its temperature will be increased. And when temperature of the given body increases, then there will also be change in the other properties of a given body. That may be a volume, that may be a pressure, that may be a length of the body. So like that, when you supply some amount of heat, there will be a change in the properties or physical properties of the particular system. Those physical properties or change in those physical properties due to the addition of heat will be utilized to measure the temperature. For example, consider a body. When you supply some amount of heat to that particular body, its temperature rises. Its temperature rises, as well as you can consider volume. Its volume will also change. Its pressure will also change. Like that, there are many properties of a particular system which will be changing with the temperature. That change in the properties of a particular body or a system will be utilized to measure the temperature of a body. So that property which we will consider is called thermometric property. Okay. Thermometer and thermometric properties are many thermometer, and those thermometric properties are given here. So let us have a look at that. So in this column we have number of thermometers. We have wide variety of thermometers we will use in physics as well as in engineering applications. And those properties are given here and symbols. So let us have one by one. First thermometer, which is constant pressure gas thermometer. In constant pressure gas thermometer, we will use volume as thermometric property. Symbol we will represent it as V. Okay. Constant pressure gas thermometer means pressure of that particular body will be constant, but the volume of the particular body or a system will be changing. This change in the volume is measured as the temperature change. So this volume will be utilized to measure the temperature change of a body. Similarly, second one, constant volume gas thermometer. In this thermometer, volume of a gas will be constant. Its pressure will be changing. This change in the pressure is used as the thermometric property, and hence this change in the pressure is utilized to measure the temperature change of a body. Symbol usually will represent it by P. In electrical resistance thermometer, we will use resistance of a particular body as the thermometric property, and hence change in the resistance will be utilized to measure the temperature. In thermocouples, we will use thermal EMF as the thermometric property. Change in this thermal EMF, electromotive force, is used to measure the temperature. In mercury in glass thermometer, mercury glass thermometer is the very general thermometer which we will use. In this thermometer, the thermometric property is length of the mercury in the glass. This length is thermometric property, and change in the length of the mercury is utilized to measure the temperature. So this is how the concept of thermometric property is. We will use particular property of a system to measure the change in the temperature of a system. So that is what the concept of thermometric property.